So a scientific study has come out quite recently. It's called Reinstruct Toward OS-Aware CPU Microcode Reprogramming. As far as I know, this has not hit mainstream news yet, so we might be ahead of the curve. Essentially, what these guys did is they took the BIOS of CPU Goldmond, I think. What is it? Goldmond? Oh man, where did it go? Yeah, Goldmont CPUs. And because it's a very particular type of CPU architecture, and what they could do is if they lowered the BIOS version, then they would enable a specific hack. It was an exploit that was recently or that was previously found to provide privilege escalation inside of the CPU architecture. And so at first, what they did was looked at how they could just downgrade the BIOS to infiltrate the CPU, these Goldmont CPUs. As an aside here, they did say that it could also work on other CPU architectures that are similar to the Goldmont one, but they didn't test it, right? So they weren't able to like definitively say it. They just said that there's a likelihood of it. So essentially, what they do here is by downgrading the BIOS of the machine, thus enabling an exploit that they knew to exist in the past, they could then read into the CPU architecture. By reading into the CPU architecture, they could do a kind of man in the middle, almost, not quite, attack on micro operations. Micro operations are things that are done inside of the CPU and typically exist as a way to essentially how do I explain this? Okay, let's try it this way. When you run an application, it runs in what's called a user level space. That's for you. That's a privileged space. The user is you. So imagine you have a password in this user space that's running in an application like your Microsoft document or your browser or whatever. That's a privileged area. When you have to do something like, I need to read a file in order to, I don't know, load the file into Microsoft Word. Now what you're doing is entering what's called system space or kernel space. That exits the user space and enters into a different space of your machine that is not bound by user restrictions. It is just a system level restriction. It's not even a restriction. It's like it's an unbounded area because you just want to read a file and then put that back into the user space. So by utilizing an exploit in older BIOS versions for this Goldmont CPU architecture, what they could do is go down into the CPU, and when you exit from the user space and enter that system space, and you want to do something like generate me a random number, they could actually go into the CPU and take over the function call for random number generation, so like rdrand. And what they could do is they could entirely overwrite that function. Anytime rdrand is called, they could make it return any value they wanted, including a static value. So then what they could do, if I go down here, they could take rdrand and they could make it so that it could read other system level calls, or in some cases, other user level calls. That was a bit rarer for them to be able to do, but at the very least, system level calls. Because you can imagine, for example, if you're typing on your keyboard and then something has to get flushed to disk, that's a system level call. And so I believe that they had, yeah, right here, they have a sudo password. So you're putting in your password to have root access to your machine, right? To gain root access to your machine. And because they could take over rdrand inside of the CPU, they could read the system level call that takes in the characters you're typing into your terminal, and then they could read those characters and they could extract your password that way. Now, the most malicious part of this is that because it's system level, there is no check against this. You can't even do like an antivirus or like hacking level software based check to determine whether somebody's hacking you. This exists at a level that is completely, like I said, unbounded. It's system level. So if somebody had the ability to take over the CPU micro operations of simple functions like random number generators, then they could extract any data that they wish without you ever knowing. It's a completely hidden system. Now, what they decided to do was they decided to turn this into good. So what they did was attempted to make a case for exposing some of these CPU level micro operations so that people could increase the performance of these micro operations on user level stuff. So, for example, what you could do is if you know that your user level system does not use rdrand for actual random number generations, but you do know that your user level system does need to use something like file operations, then you could take that function, that rdrand function, and you could appropriate it for a user level function. So you could essentially bridge the gap between system level and user level. What that means is that here's an example that they did, right? So they take 0ext and they take rdrand and they return the actual CPU ID, the core that the user level microoperation is using, or that the user level microoperation is executing, and statically return, instead of a random number, statically return the CPU core ID so that you could enhance the performance of get CPU function calls. So they tried to turn this on its head and say, well, can we use this in a positive way? So then at the end, they made the case that while these CPU microoperations and the architecture and whatnot is a closely guarded secret, and that these are the kinds of ways that researchers have to use in order to determine how CPUs work. Essentially, a lot of researchers have to use these exploits in order to figure out what the architecture looks like inside of CPUs, because the CPU manufacturers aren't going to tell you. They're not going to put out like a document or a PDF explaining to you how everything works and whatnot. So you have to use these kinds of things to figure it out. But on the positive side, this paper says, well, maybe you should make a way for us to be able to patch into microcode operations in a very specific set of use cases so that the user level can benefit from not having to exit, thus incurring a cost, exiting the user level, going to the kernel level, and then jumping back in. Maybe we can make these micro operations more performant, and there's a way to do that safely. And so they make that entire case. So I thought it was a very interesting article. I learned a lot about kind of how micro operations work. It was really interesting to see how it could be used to gather data from your machine without you ever knowing, including things like this. Right? I thought it was a very interesting type of study. Probably causes memory errors, though, crashes your computer. I suppose that it could, and it depends on how it's being used and where. It's probably contextually, right? It matters. Context matters in that case, but it's not always true, because if you know what you're targeting, then you're probably going to have some idea of whether or not for example, you could target programs that on the user level are not going to be dependent on these micro operations inside of the CPU architecture, and you could safely take them over and do stuff with them, and do what you need without anybody ever figuring it out. But I would imagine that there are cases where yes, my tech it could cause issues, but even then, that's not an indication that you've been hacked, right? It's an indication that there might be something wrong with your machine. And so you might go and like buy more RAM or something like that, or like replace your RAM, replace your hard drive. Like there are other, that's really the problem, right? Is that this is an undetectable method because you don't actually know that this has happened.